All right, so what we're going to do today is we have graphed from standard form. We graphed from vertex form back in chapter 2, and then there's this other one called intercept form. So different parts give you different pieces of information. So in the quiz that you just took, we just found the vertex from standard form. So repeat it and remind me, how did you find the vertex?
Negative b over 2a.
Yeah.
And then c is what?
Negative b over 2a, and then the y is, plug it in, okay? Way long ago, Mr. Ganiko, we are back on class time. On vertex form, do you remember that you can look at that equation in vertex form and just yank it out?
H, okay.
Good. All right, so there's the x part of it, and there's the y part of it. All right, so we are going to work on intercept form today and what that means. So you probably don't know this one. So we have this P and we have this Q. So this is like one x coordinate, and that is another x coordinate, and the vertex is halfway in between any 2 points. So to find the x part of it, you're going to go P plus Q divided by 2. That's like the midpoint, like the average, the middle. And then for the y, it is going to be, plug it in. Okay, so you got a vertex, right? And you got the axis of symmetry. So can you remind ourselves what in the world an axis of symmetry is? It's the line that cuts it in half, okay? So do you know what the axis of symmetry is from standard form? Where does the axis go through? The x line of the, say the V word, vertex. So it goes through the vertex, and it is the x line. So right here, it is negative b over 2a. It's the x coordinate. It's the line that goes through it. In vertex form, what's it going to be? Which one is the x in HK? The h, because there's your x and there's your y. So it's just going to look real weird, but x equals h. And then where is your axis of symmetry on intercept form? Right there, P plus Q divided by 2. All right, so a parabola opens up if a is greater than 0. What's another normal way of saying a is greater than 0? A is a positive number, good. If a is greater than 0, we're just saying a is positive. It opens down if a is less than 0. What's a normal way of saying that? A would be negative. All right, so we're going to graph from intercept form today. So we want to find the x-intercepts, the roots, and all kinds of stuff. All right, so If it's in intercept form, that means it's in parentheses. So intercept form means that it is in the factor form. So right here, instead of it being equal to y, we're going to set it equal to 0. So if you want to know where it crosses the x-axis, what your x-intercepts are, you set y equal to 0 and solve for x. So maybe you're not entirely sure what to do with this negative. You know what to do with the negative? That would make life real hard. No. I would ignore it. Here's why I can ignore it. Because when you set it equal to 0, that's like having a -1 there. If you divide both sides by -1, what's 0 divided by anything? 0. And then those two terms cancel each other out, and then you get x minus 4, x minus 8. So what have we done many times? What have we done many times? How do we find your x-intercept? Split it. So when you split it, if you have x minus 4 equals 0, what would x be? And what would your other x be? All right, so these right here, these are your x-intercepts. They're the solutions. On a test, a quiz, or the ACT or the SAT, they may also call them roots. They may also call them zeros. Zeros, x-intercepts, solutions, and roots all mean the same thing. Kind of not really if you're a real mathematician, but for Algebra 2's sake, they mean the same thing. All right. So these are my x-intercepts or roots. Check. We did that. The next thing it says is go find the axis of symmetry. I wonder why I did it like this and didn't just do example 2 and 3. I don't know. Okay. So the axis of symmetry, when I come up here and I'm looking at my chart, because I'm in intercept form, it says take P plus Q divided by 2. So right here, here is my P, and here is my Q. So I have 4 plus 8 divided by 2. Pass them back. One goes to Kylie, one goes to Dizzy. All right, so 12 divided by 2 equals 6. So you have an axis of symmetry at x equals 6. All right, so now I want to find the vertex. So right here, the axis of symmetry and the x of the vertex are the exact same thing. To find the rest of the vertex, right here it just says plug it in. So this says plug 6 in for x. All right, so I have y equals negative, parenthesis, 6 minus 4 times 6 minus 8. don't distribute, do the math, multiply, and then change the sign. That would be the smartest way to do it. Math, multiply. Did you get 4? Okay. All right. So therefore, I know that my vertex is at 6, 4. The last thing was, does your graph open up or down? It does open down because this one opens down because you have that negative right there. So that is basically saying that A is -1. And if A is a negative number, that is how I know that my graph opens down. You ready for example 2? You ready? Let's do it. All right, so first thing we want is my vertex. All right, so if you were to take this and you were to solve it, and you were to break it apart, so essentially whatever A is, it's kind of stupid and you can ignore it. Why? Well, because when I want to solve, I'm going to set that equal to 0. And if there's a number right there, I'm just going to divide it away, and I'm going to end up like scratching it out. So right here, if I have a parenthesis of x plus 3, I know that I have a solution at where? -3. And right there, when you see x minus 1, I have a solution where? Okay. All right, so what I really did first is I really found the roots first. So if you were going to label this, so in this format, I really found the roots. So they are at -3, 0, and 1, 0. I'm going to graph them as I go. -3 and 1. So when you find your roots, or your solutions, or your x-intercepts, now I know that it's crossing there and there. So, your vertex, I'm going to go with your axis of symmetry is always halfway between any 2 points. So, when you look at that, when you like count in, or you can visually see it, what's in the middle of those two? Yep, -1. So sometimes on these, if you have to graph it, it's just easier to plot these points and then split the difference instead of doing the formula. So right there, that is your axis of symmetry at -1, because it's halfway in between any 2 points. So basically, I did that at step 2. So your vertex is going to be step 3. How am I going to find where my vertex is? Starts with a P. Plug it in. Okay, let's plug it in. So into my formula, y equals to times x plus 3, x minus 1. I'm plugging in -1 for my x. So into my formula, I got rid of x and I plugged in -1 in those two spots. PEMDAS says do the math in the parentheses first, so do the math in the parentheses, do the math in the parentheses, and then multiply the three numbers together. So in the first parenthesis, that added up to 2. In the second parenthesis, that added up to -2. And when I multiply 2 times -2, get -8. So my vertex, now I know, is at -1, -8. All right, so right down there, there's where my vertex is. Should be the only point on your axis of symmetry line. Fourth thing I'm going to do is find your y-intercept. So if I want to know where the graph is crossing the y-axis, so here's my reasoning for this. So that's at 0, 2, 0, 4, 0, 6, 0, 8. So anywhere along this y-axis, the x value is always 0. So I have 0, 2, 0, 4, 0, 8. So when I want to find the y-intercept, I'm going to set x equal to 0 in my equation, run the numbers, and that's how you find the y-intercept. So I got rid of the x, and I plugged 0 in. Do the math, and then multiply the three numbers together. Did you get -6? All right. So I have a y-intercept at 0, -6. Now I'm also plotting that point, so your y-intercept is right there. That is 1 to the right of the axis of symmetry. What am I about ready to do? Reflect it and put 1 to the left. I have 5 points. I have more than enough. So I'm going to go through and I'm going to kind of connect the dots and sketch it in. Alright, so my vertex is down here at -1, -8. Domain, you've got this. What's the domain? -infinity to infinity. Range, you can do this one bottom up. What's your range? Good. -8 to infinity. All right. My superstar athletes, you ready? Okay. Yep. Mathletes. Athletes, mathletes. So you see that 2 there? My A? On a parabola, that kind of, a little bit, tells you the initial stretch of the problem. So, the slope of the problem. So if you knew the vertex, and I knew that my A is 2, I'm like, oh, I can go up 2 and over 1, and that always matches initially. That only gets you like 1. You can't keep doing it because it's not a line. You can't keep going like up 2 over 1, up 2 over 1, because it doesn't work. You can use it for like one time from the vertex out. Because from here, it's going to go like up, how many? More. All right, I'm going to hit the pause button. You guys do the next one. All right, so here's what the rest of the graph looked like for example 3. So the first thing that I did is I took those points right there and I set them equal to 0 and solve, and I found my roots, aka my x-intercepts. So that's how I have the point at -2, 0 and 6, 0. The second thing you should do is find your axis of symmetry. You could do the formula, however, if you have to graph, I think it's easier to just count in, and so 2 is halfway in between these two numbers, and so that's how I knew to draw in an axis of symmetry at x equals 2. So your vertex is somewhere on this line, somewhere. So I took 2 and I plugged it in place of x into my equation. I ran the numbers and I got 8. So therefore I knew that my vertex is here at 2, 8. So that's the third thing I did. The fourth thing is I found my y-intercept. To find a y-intercept, you set x equal to 0 and solve. So this is me finding the y-intercept. I plugged 0 in for those two x's. I run the numbers, and it's off the screen, but you get 6. So now I know that I have a y-intercept at 0, 6. This is 2 to the left. I reflect it. I got another one 2 to the right. I have 5 points, and so I sketch it. My domain is always -infinity to infinity. My range goes bottom up, so this is pointing down to -infinity. So it goes -infinity up to 8. We'll do the back side tomorrow.